But there is one question or one problem I want you guys to look at, and I think it was that one. It was right after the iron 3 sulfide. So, and this is what we're doing today. Okay. Molar conversions for compounds. Now, yesterday you got to convert grams to moles and moles to grams, and then also calculate molar mass. So you're still going to do the molar masses, but I'm going to add one more component to your moles, and that's going to either molecules or atoms, or from the opposite, where I start with either the molecules or the atoms and go to grams. So we'll be using a few more steps than just one step in our dimensional analysis or factor labeling. So here is a practice problem, and then I'll work out a couple of the problems that's on your sheet. But before I do that, here are the steps that we need to know. That, say, like if I start off with kilograms, which I don't in this problem, but if I did, we would have to go through a series or a process to get what we start with to moles. And this is kind of leading into what we'll talk about next topic, which is stoichiometry, which that S word doesn't mean anything to you. That'll actually be one of your curse words that you'll say to yourself. But if I want to convert kilograms, and say that we're going to definitely need our periodic table, so if you have your periodic table out, if you don't, get it out. Let's see here, load that up. Okay, so we'll be looking at our values here. Okay, so again, what does that value underneath the symbol represent? What is that? The molar mass. So it's the number of grams that represents 1 mole of whatever it is that we're looking at. Or, even better, 6.02 times 10 to the 23 atoms. Okay, so that's what that value represents. So we need to actually become aware of that number because we're going to use it today. So looking at this, where I convert kilograms, when I look at the periodic table, these values here are in what unit? Grams. Okay, so grams. So if I were to give you something in kilograms, okay, then we would have to convert the kilograms to grams. So that's a process or a step in the conversions that you would need to do. And then once you have that value in grams, then you can convert to how many moles you have. Okay? And then from there we can do a lot of fun things. We can find out how many molecules we have, or if we don't have molecules, how many atoms we have. Or if we do have molecules, then we can possibly find out how many atoms. But the process there is, if we do have molecules that make that up, then we'll convert to molecules, and then we can convert to atoms. Now, there's something that's very, very interesting when going from mole to molecule. Whenever we type or write, not type, but whenever we write the value for mole within our problem, we're always going to make that value 1. So it's always going to be 1 mole. So when I ask, okay, how many grams is in 1 mole of sodium, you would say 22.99. How many moles are in 1 mole of chromium? You'd say 52 grams. If I were to say how many molecules are in 1 mole of chromium, then you'd tell me Avogadro's number. But it's always going back to 1 mole. So keep that in mind whenever you're working out a problem. But when we go from here to here, then we're multiplying by Avogadro's number. So if I am working and converting from kilograms to grams, grams to moles, moles to molecules, molecules to atoms, when I go from moles to molecules, I'll multiply by Avogadro's number. If I'm moving in the opposite direction, say I start with atoms and I'm looking for kilograms, then I obviously would do my conversions in the reverse direction. If that were the case, I would have molecules and converting to moles. What do you think I would do with Avogadro's number? Divide it. And again, you don't have to memorize that. It'll be automatic because when you work out your problems, if it's not the unit you're looking for, you're going to slide it diagonally. Okay? So unfortunately, this problem doesn't get as involved, but we'll definitely work one that does. Okay, so that is the process in which we're going to work the majority of these problems out. And like in this problem here, and I'll try to lead this up, the question asks, how many molecules are in 3.98 moles of aluminum hydroxide? What unit do we start with? Moles. So the nice thing is here, we're going to start right there at moles. What's the question wanting to know? How many molecules? So we only have in this problem a one-step process. So here's what you don't do. Always realize that this is a one-way street, okay? If you start with kilograms and I need to find out how many atoms we have, this is the path you go. If we start off with moles and I want to find out how many atoms or molecules, that's the direction you're going. You're not going to go back to find out how many grams you have and then, just interestingly enough, how many kilograms, and then convert those kilograms to grams, then back to moles to get the molecules. So like if I want to get to SAM, I'm not going to go back this way and then go around. I'm just going to go straight to them. All right, so in a process like this, realize what you're looking for and where you're going, okay? So, or the reverse there, where you're going and where you start. So if it's, and some of you will try to do this. You'll be given moles and you'll want to find out how many grams so you can find out how many molecules. Don't do it, all right? So let's work this problem out and then we'll work a few more. Okay, so again, what do we know about this problem? Or what's given? Yeah, so you have 3.98 moles of aluminum hydroxide. Now what's even nicer about that? I don't even care about this. Why? Because for anything and everything, if I have 1 mole of something, it's still equal to 6.02 times 10 to the 23. So I really don't care what the compound is or what the thing is. And you'll see me do this on a test. And I'll tell you, I'll do it on a test. I'll make up some really ridiculous compound that probably has about 30 or 40 different things in it. And some of you are going to try to find the molar mass for it. You don't need to. Just go from moles to molecules. So if it's not the unit you're looking for, move it diagonally. And if we have mole within the problem, what value you want to put there? 1. Okay. And then how many, we're looking for molecules. How many molecules are in 1 mole? Very good. And if you forget it, flip your periodic table over. It's on the back. I think it's in the top right-hand corner. I hope it is. Can somebody confirm that? Top right-hand. Yes, no? Anybody find it?
Yeah, it's probably up there. 'Cause the other one's up there.
Probably up there.
The other one's up there. Yes, it's up there. Yeah. It is. This is 6 marks.
Okay, so yeah, it's the third one down,
Yeah.
top right. So if you just freeze up and you're like, "Argh," just look on the back of your periodic table. That value will be given to you somehow, some way, so make sure you know how to use it. Now, make sure that you can type this in. Okay? That's probably more important for today, making sure we can type these values in. So my calculator says 2 point, what is that? We'll say 40 times 10 to the 24. My calculator actually says 3.395 blah 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 times 10 to the 24. Okay, I just went ahead and rounded it. Is everybody able to get that? Remember that if you have the EE button, okay, so 6.02 EE23, that'll give you this. Okay. Or the EXP button. Okay. Let's take a look. Everybody good with that? Okay, let's take a look at your homework here. Question number 7 on your homework. Question number 7. Again, those first 6, I believe, are just molar mass, the things that you did last night for homework, so I'm not going to work any of those out. You're pretty good at those. Just more practice for you. So here, and again, try to remember your sequence. So kilogram, gram, mole, molecule, and or molecules, whatever, atoms. Okay. And then it can go in the reverse direction. But it, again, remember, it's a one-way street. Now, sometimes we can bypass molecule and go straight to atom if you do not have a compound. If you have a compound, you got to go through molecules before you can get to atoms. Okay. All right. So let's do this first one. So again, 58.7 grams. What are we given? Grams. So we're starting here, right? And the question wants to know number of moles. So how many steps? 1. Are you going to use Avogadro's number in this problem? No, that's what we did yesterday. So pretty bad example I just gave. So start with what you know, 58.7. Don't worry, there's more. And we're going to look for 1 mole, or what the molar mass for copper oxide is. Copper has a molar mass, yep, 63.55. Good. Oop, go back. So 63.55, and oxygen 16. So my molar mass, and again, you don't have to do this. I just do it to make sure everybody's on the same page. So 58.7 divided by answer. So 0.73, 737, 738. Okay. So just like what we did last night. So no big issue there, I hope. Okay, let's take a look at number 12. Now it's starting to get into some fun. Okay, so here number 12 says 12.03 kilograms of sulfuric acid, H2SO4, and it wants to know how many molecules. So in this problem, we're starting with kilograms, and we're going to what? Molecules. So we're going to go here. Okay. So starting with kilograms, going to molecules, so you're going to have a 1, 2, 3 step process. And that's probably a good way to do that. Just have this written on top and then realize, okay, I'm starting here, I need to go there, so I need to convert the kilograms to grams, grams to moles, moles to molecules, and I'm done. So start with what you know. So I have my 12.03 kilograms. And again, kilograms is not what I want, so move it diagonally. And what am I converting that to? Grams. And which one's bigger, kilogram or gram? Kilogram, very good. How many grams in a kilogram? 10 to the third. Okay. Again, retrieving the information from the past, we love it. Oop, come back. Okay, so again, what's the next step? Go to mole, very good. So if it's not what we're looking for, we're going to move gram here, and 1 mole on top, and it's sulfuric acid, H2SO4. Actually, I'm going to erase that gram unit. So looking at hydrogen, we have 2 of those, 1.008 from the periodic table. And sulfur is 32.06, good. And how many oxygens? 4 of those. Okay. Okay. And we have one more step, right? So we need to convert the moles to molecules. So if it's not the unit you're looking for, move the unit diagonally. And notice, 1 mole, 1 mole. Okay, so whenever you have mole within the problem, until otherwise stated, leave it as 1. So how many molecules are in 1 mole? Very good. 6.02 times 10 to the 23. I'm just going to call that molk. If you want to abbreviate molecule, you can put mol. How's that? Unless you want to write out molecule. That's your call. Now, here's something I want you to recognize. Look at the units. Kilogram, gram, mole, molecule. So whichever direction you're going should be kilogram, gram, mole, molecule on top. If we're going in the opposite direction, then these units will be on top, going in the opposite direction. That's one real quick way to make sure that you're doing the right process here. Okay. Now, let's see if you can type all that in. Here's how, if you're going to do it all in one fell swoop using parentheses, 12.03 times 1 EE3 times 6.02 EE23 divided, open up that parenthesis. There's our first parenthesis. And then all of that, 2 times 1.008 plus 32.06 plus 4 times 16. Close that parenthesis, hit your equal sign. That'll give you the correct answer. Okay. So order of operation takes care of this, and then once we hit that divided button there, now we have to tell the calculator we're going to do some multiplication down here, but we want to take care of that first. Okay. Anybody get a number there? 7.38 times 10 to the 25th? And what's my unit there? Molecule. Okay. Very good. So in 12.03 kilograms of sulfuric acid, there are 7.3 times 10 to the 25 molecules. More than I could ever count, or would want to count. Okay. Want to do one more? Sure, it's my homework. Let's look at number 15. Okay. And we're going from grams to atoms this time. So our sequence, so we have, so now we're starting here and we're going here. Okay. Can I bypass molecule? No, because I have a molecule, so I don't want to do that. That would only take place if I gave you a single type of element, which I'm not doing yet. All right, so here we go. Start off with what you know. So 79.54 grams. Actually, try this on your own. Try this one on your own. Don't peek up here. Okay. See how you guys are doing here. And TA is right next to tungsten, below vanadium. Not one of your 52s, so don't freak out about that. Now the last step is interesting. In one molecule of Ta2O5, how many atoms are there? How many? In one molecule of Ta2O5, how many atoms are there? 7. 2 plus 5 is 7. Okay. So here's when we look at our, remember our verticals? These things are equal to each other. Okay. So in one molecule, I have 7 atoms. In 1 mole, I have 6.02 times 10 to 23 molecules. In 6.02 times 10 to 23 molecules, I have 1 mole of something. And in 1 mole of Ta2O5, whoop, that's a bad 5. I have this molar mass, whatever it is. Okay. So keep the columns equivalent. Okay. And let's see what we did here. Times 10 to the, was that 23? Multiply on the top. Here's how I type this one in. Actually, I didn't use parentheses until the bottom. So 79.54 times 6.02 EE23 23, still no parentheses because order of operation is keeping that intact. Times 7. When I hit that divided button, then I open up the parentheses. Then I just type all that in, close the parentheses. Now, and I realize that I write with parentheses here. I apologize for doing that, but I'm trying to show a break in the action, so to speak. In other words, that these two are together and these two are together, divided or separated by a plus sign. Don't necessarily type it in as I write it. That's just one way that I help to separate what's going on there. Yeah.
Do you have to open up with parentheses? Like, I typed it in where I just typed it in exactly how it is, like how you did it, except without those parentheses that you just put after the division sign, and I got the right answer.
With this problem?
Not necessarily that problem.
Yeah. I would be careful because if you have something like this with multiple values, if you did this times this and that was that, as soon as you hit that plus sign, it's going to take whatever's on top, multiply it out, divided by that, and then it's going to add this top part right up here. It's going to put it right here in the equation. So that's what the parentheses do. It helps to keep it in the correct spot, which is down here. Ooh, that was interesting. Okay, so just be careful on that. Wow. Any other questions? Right, good. All right, so work on that worksheet.